We'll kick off the day with some Abrahamic religion. So we built an int list last time. This data structure, it does all the stuff a list can do, right? You can add stuff to it, you can take stuff back out. It's a sequence of items with a front and a back, all that stuff. Now the specific implementation that we used was we had an integer called first and a pointer to the rest of the list called int list. Now this data structure, while you may not have realized it, was what I call a naked recursive data structure. Now we'll get a sense for what that means as we move forwards, but basically the idea is it seemed perfectly fine at the time, but now this lecture, the fruit of knowledge, is going to reveal to you the grim truth that in fact we were naked all along. So in this lecture we're going to seek clothing. We're going to make the int list more like something that's conventional to Java programmers. Now there's nothing wrong with int lists or nudity or whatever, it's just, it depends on your culture. But in the Java culture, having a naked recursive data structure is strange. Now in other languages, like the scheme-like languages or in functional languages, you can do naked recursive data structures all day long, but in Java, it's just a little awkward. To get a little bit of a flavor for why they're strange, imagine the novice programmer in Java trying to write code that uses int lists. For them to be able to effectively write code, they have to be able to know how references work in a pretty deep way. The recursion is right there, right on the sleeve of our naked data structure. A sleeve. That's kind of a weird mixed metaphor, but okay, we'll go with it. But so an int list, you have to know how pointers work in order to understand what an int list is. The new thing we're going to build, not the case. So how are we going to do that? What's this new data structure going to look like? Well, the first step is we're going to do a rebranding effort. Okay, so nudity, that's so 7,000 years ago or however many years ago. So we're going to change things. Instead of having an int list class, we're going to have an int node class. And all that cruft, all of those methods that we had in here, we're going to strip them away to become clothed. I don't know what's going on with my mixed metaphors, but hey. Okay, so I'm going to delete all those methods. That's the stripping away. And then we're going to rename this to int node. Int node. And int node, and int node. And then I'm going to take these other variables, and I'm going to give them new names. Instead of first, I'm going to call this item. And instead of rest, I'm going to use next. And then I'll rename these as well. Seems nicer. Okay, and I'm only doing this painstaking process because I want to make it clear exactly what we're doing. Okay, so that's the new int node class. It's like an int list. We just took all the methods away, and it compiles. Good. So now we've done this rebranding effort. We observe that int node is now a dumb class. It has no methods, but we're going to bring back the functionality. Do not worry. Now, of course, you might say here, this is not any kind of improvement. Nothing is better about this, and you're right. But we'll get better, right? Things will improve. So the next step we're going to do, and this is going to seem like an almost seemingly equally pointless exercise, is we're going to create another class, which I'll call SLList, with two L's. And this class is going to represent, let's see, this is an SList is a list of integers which hides the terrible truth of the nakedness within. All right. And how this list is going to work is, we already have a perfectly good int list class, right? I mean, it's called int node now. So I'm going to make one called, I'm going to make a variable in SList called public, I'm going to declare a variable in SList, so it'll be public int node first. And then I'll have a constructor for SList, public SList int x, first equals new int node x null. And at that point, once I've written this class, I can do something like SList L equals new SList 10. And what this code does is creates a list of one integer, namely 10. All right. So what's good about this? Why have we done this seemingly pointless exercise in bureaucracy? This is a little bit of a clue. If you think about how I, some programmer, have created a list, I did not have to actually specify a null, right? An SList does not have that property. You just give it an X, and that's it. So if we compare the old way of doing things, int list to int nodes, we can look at the declaration of a new naked recursive list, looks something like this, and a new hiding the nakedness from the world list. Okay? So int node, in this case, we see that we have to specify the address manually. Now that's also a pretty minor improvement, right? But it gives us a sense of where we're going with this, right? The programmer who's using an SLList, they need not think about references. They don't have to specify the null. And that same property is going to recur as we build up our other methods. There'll be no need to even be thinking about any of this naked recursion. Now we stripped away all this functionality, right? We took away all the things that int node could do, so we're going to put it back next. And we're going to do it by adding a couple of simple methods first. They'll be called add first and get first. So let's jump right in. And you're welcome to pause the video and ponder how you might do this. I always, when I watch lectures, I do that, right? When someone's about to code something, I try and anticipate their next moves. Or if I'm watching a math lecture especially, because then I feel like I could better appreciate the thing the teacher's about to do. So in this case, I'm going to have public void add first. And what does this method do? Adds, should have a parameter. Adds x to the front of the list. Okay, how should that work? Well, first, presumably should be a reference to the front of the list. So what I really ought to do is say something like, well, maybe I'll look to my int node or my int list class for inspiration. That might be the easiest way. I'm lazy. I don't want to do any thinking. Size. Here we go. This is what I wanted. So when we added to the front of an int list before, we had something like this. So looking at the same pattern, I can basically say, oh, okay, the first pointer should really just be a new, in this case, int node. I'm going to put in, x in first. And that piece of code is just like what we did before. Now, if you didn't quite understand the sleight of hand I did to build this method, right? If you don't quite get what this line of code is actually saying, well, the previous lecture we spent a little more time with it. I'm not going to go through it in great detail again, but remember you can always put this code through the visualizer and see what's going on. I could, no, but I won't because it's in the previous lecture, but you can break this up into multiple lines, and that's an exercise you might do in order to help understand it. So that's what add first should look like. What about get first? That one will actually be a little easier. So this one returns the front, or the first item in the list. Okay, and so in this case, that's pretty straightforward. All we need to do is say whatever the first reference goes to, whatever int node that is, we'll just return that that int node's item. And this right here gives us our SLL list. Okay. So suppose we wanted to make a list of the numbers. We still have a main? Yes, I'll move it down. So let's suppose we wanted to, sorry about all the scrolling. Okay. Get you situated. All right, so here's my class, there's my constructor, add first, get first. So main, when we want to make a list of, say, the numbers 5, 10, 15, it might look something like this. L.add_first 10, L.add_first 5. And now if I print get first, hopefully I should get back 5. So I run this and I get 5. Great. So let's compare what we did in this context right here. This is SLList, right? This is all the code we just wrote. This is the int node class. This is the example usage we just wrote. Let's compare what we did with this clothed or non-naked recursive data structure with what we would have done before, okay? On the right, we see what it's like to use a naked recursive data structure. You want to add something to the front? Well, L equals new int list L comma 10. By contrast, with our SList, we say L.add first and put in the number 10. So hopefully it's clear when you look at this. This just reads easier, particularly if you're a novice. Now again, there are some programmers who prefer and enjoy programming that looks and feels like this, and they're not wrong, but the normal Java convention is something like what we see on the left. So a visual picture of this whole story, on the left, or sorry, on the top, we see the naked recursive data structure, where crucially, anytime we're working with a list, we have pointers directly into the raw stuff of the list. I may have one variable that points to the front of the list, another variable that, uh-oh, my phone's ringing. Hello, hi, you're in a video on the internet forever.
What?
Oh, I was recording a video for class.
Oh.
So I'll call you right back.
Oh, well, I'll just take a night then.
Oh, okay. Okay, how'd it go?
Yeah, seems okay.
All right, good. Good to hear. Excellent. Alrighty. Well, have a fine night, and I'll talk to you later. All right, bye. Bye. Okay. So anyway, this top link or this top picture, we see there's these pointers that go directly into the list, right? You get to see it. By contrast, if we're using an SList, you get a pointer to a middleman, and this middleman says you can only access this data through my methods add first and get first, and ain't no way to get around it. Or is there?